Hello and welcome to any combo lords watching this in the future. Probably not any or many watching in the present because I didn't announce this in advance. I was just going to film a little video about prime numbers and figured I'd do this one live to still get a video for any future watchers and then be able to answer a few questions and chat with you guys, anyone who manages to stumble through here in the next hour or so. Now, it may be a little noisier than usual in the combo classroom. You may notice my neighbors seem to have their kids having some sort of party, but I can't complain there. Kids got to have fun. I don't own this neighborhood. Still got enough noise range for us to talk about some prime numbers. So, what I wanted to look at today is how, if you look at the first prime numbers that are the one-digit ones, those are probably easy to keep stuck in your head. You got 2, 3, 5, and 7. And all the other numbers up through 10 are either 1 or are combined from some of these primes. Like 10 is 2 times 5, 6 is 2 times 3, 8 is a couple 2s, and 9 is a couple 3s. Well, 8 is 3 2s total, but really it's all 2s in its structure. And so any composite number is going to have some prime factorization that builds it up. And if we wanted to know all of the two-digit primes, that might seem like a harder thing to keep in our head. And it might seem like it would take a minute to calculate them all because there's a lot of possible factors that could go into a two-digit number. But there are a lot of shortcuts we may be able to bust out. And by just using a few shortcuts, it's going to be surprisingly easy for me to calculate all the two-digit prime numbers right here. So the way we're going to do that is first think, I could write down all of the two-digit numbers and then start crossing out the ones that aren't prime, that have some factors making them up, till I'm left with only my primes. But to take a shortcut, why even write down ones ending in an even digit or ending in the digit 5? I know those are going to be divisible by 2 or 5. We can instantly spot a prime ending in an even digit isn't prime, I mean a number, and that something ending in a 5 is divisible by 5. So let's only worry about writing down all the two-digit numbers that end in a 1, 3, 7, or 9. Those are the digits that have no factors in common with 10 or are co-primed to 10. No factors greater than 1, of course it means. And so those are the ones that a two-digit prime could end in. Now, of course, not all these are going to be prime, but just by writing down these possibilities and then taking one or two more steps of cancellation, we'll be left with what our primes are. Now, basically what we've done here, once we write all of these down, is eliminated all the evens, which also eliminates all the multiples of 4 and 8, of course, eliminated all of the multiples of 5, and anything that's a combination of those, like a multiple of 10. So give me one moment to write down the rest of these, and then we're going to play our next elimination game. While I'm setting these up, see if you can guess what would be the next step that would be easiest and most efficient to cross off of this list. Well, the multiples of 5, we only really did so early because they were easy to spot in our base. They ended in a 5 always. So these are all the two-digit numbers that end in 1s, 3s, 7s, and 9s. And if we've already eliminated all of the ones that have 2s making them up and 5s making them up, our next logical step is going to be 3s. Not only because that's going to be in the most of them, but also because 3-even numbers are easy to spot in our base, because 3 is a factor of the number 1 less than 10. That gives them the superpower where the sum of their digits is 3-even, if and only if they are 3-even, by which, of course, I just mean a multiple of 3. So we don't really have to try and go to every third number with these gaps and try and spot it that way. I can see which of these have their digits add to a 3-even number. And any of these whose digits add to a multiple of 3 will become eliminated. So we go through and add these digits in our head: 2, 4, 8, 10, 3. We're crossing that out because it must be 3-even itself if its digits add to that. 5, 9, 11, 4, 6, 10, 12, 5, 7, 11, 13, 6. 8, 12, 14, 7, 9, 13, 15, 10, 12, 9, 11, 15, 17. And let's see, these were 16 and 18. So now we have crossed off all of the three-vins by checking which ones have digit sums that are three-vin. Now, out of the ones that are left, there's still some that aren't prime, although at this point, most of them are prime. Because just by having checked the 2s, 3s, and 5s, we've achieved a lot. If we look at what makes up a number that's 2 digits, if it's not a prime, it has some factors that make it up. And each factor must multiply with another factor into it. Say I'm looking at the number 100. For 100, right beyond where the 2-digit numbers end, it is 10 squared, 10 times 10, but it also has other pairs of factors, and for each factor, apart from the one that's exactly its square root bigger than that, like 50, it must multiply with a factor smaller than the square root, 50 times 2, 20 times 4, or etc., 25 times 5. There's pairs of numbers that are bigger and smaller than the square root, one of a bigger and one of a smaller per pair. Or when you're lucky, you also get a number times itself if it was a square number there. But what this means is that any composite number has a prime factor that's at most as large as its square root. For if there weren't any that were the square root or smaller, what are these paired up with to multiply to that? So all we need to check are the primes that could multiply up to the square root of the number, all the multiples of those, and then we're pretty much set. And if we think of what that means for 2-digit numbers, by the time we're even at 11 squared, that's 121. So since 100 had a square root of 10, any 2-digit number is going to have a square root less than 10 of a single digit, meaning that any 2-digit composite number needs some prime factor in it that is less than 10, one of these 4. So if we've eliminated all the 2s, 3s, and 5s, anything on here that's not crossed out yet but is still prime must have a 7 making it up. Because if it didn't have a 2, 3, 5, or 7 in it, what are the other supposed factors paired with? So now we just really need to check multiples of 7. But since 7 doesn't have as easy of a divisibility trick in our base, we don't even need to go through each of these and try and check for 7. We only need to check a few multiples of 7. We're not going to need to check things like 7 times 6, because a multiple of 6 is one of these evens and three-evens we've crossed out. We're not going to need to check something like 7 times 8. That would just be even again. We're only going to need to check 7 times other primes, because any other one up to that point might just have the 2, 3, or 5 in it, that we already crossed those out. So what's the biggest prime we'd need to check 7 against? Well, by the time we get to 7 times 15, that's already greater than 100. That's no longer 2 digits. So the only ones on this list that could still be composites secretly would have to be 7 times something less than 15. And if it's 7 times something even, three-even, or multiple of 5, that's already covered. So we only need to check 7 times 7, 7 times 11, the next prime, 7 times 13, and by the time we get to the next prime, 7 times 17, that's too big to be 2 digits. So if we just check these 3 cases, 7 times the primes that are bigger than what we've already crossed out, but smaller than the point that the multiples of 7 are no longer 2 digit, then we're going to be done. So 7 times 7 is 49. 7 times 11, the other one we need to get is 77. And 7 times 13, we can think means we got 70 plus 21, that's 91. And so 91 gets crossed off too. And we are left with our prime numbers. Let me know if for some reason I made an error in the comments. I'll double check this with a list right now. But I think that logic should be sufficient to have generated all of our 2-digit primes. And yes, this one needs to be watched probably in a row. So people are probably going to need to rewind it or watch it later if they want to fully understand that. Now I'm going to pull up a list of prime numbers and let's go through and see if we generated them right. Now, hopefully I generated the 1-digit ones right, or our whole process is going to be off. Now, the 1-digit ones, of course, are going to read 2, 3, 5, 7. And from there, let's see how well we got. We got 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, and it's perfect. None missed, no too many, no too few. So not that hard to have found all the 2-digit primes. Now, of course, to find all the 3-digit primes would take a lot more time, but you could use the same procedure. We need to think, what's the square root of 1,000? Turns out it's 31 point something. That means that any composite number less than 1,000, if it's not a prime itself, has a prime factor, that at least one of its prime factors must be 31 or less for any of the composite numbers under 1,000. And so we would basically need to make a similar list that ends in 1s, 3s, 7s, and 9s, then eliminate all the 3-vens, and then we would need to find a lot more combinations of ways we could combine different primes between like 11 and 31 and stuff, as well as like further multiples of like 11 times a bigger prime and stuff. We would need to check a lot more cases, but we still would know that any composite number under 1,000 must have at least one prime factor smaller or equal to the square root of 1,000, which, since it's in between 31 and 32, essentially means must need a prime factor, in that case, 31 or less. So the classic way of eliminating prime numbers is to cross off every second number from a list, cross off every third from a list, cross off every, you don't need to cross off every fourth, those are taken care of, cross off every fifth from a list and stuff. And those will eradicate all the non-primes and do the job just fine. And it's, even though it seems like an inefficient method, compared to some of the more precise ways of looking for where primes are, it can actually be the most efficient way for computers to test them sometimes, among shortcuts that they can apply to that. And when we're going through and factoring larger ones and looking for them, yeah, 1,000 would take a lot more time, but it's good to remember that if we played the game of eliminating all the multiples up through 31, and we could even take shortcuts with which ones we eliminated, then that would take care of all the 3 digits. So thank you for joining me for that random stuff. Let me take a peek through the comments. Thank you all. And today, like I mentioned, will just be a shorter little stream that was going to be like a little video where I wanted to just explain that little prime hunting concept. But while I'm around, I figured still got another half hour to rant about a few more mathematical topics on my mind, as well as maybe answer some fan questions and stuff. Now, of course, this channel is moving so fast that it's basically time for another celebration. We're not quite there yet, but we're almost on to the next highly composite number. And not only the next highly composite number, but a superior highly composite number. So that makes sense to be our next topic right now, is what is a superior highly composite number? Well, it's a weirder trait, a more specific trait that you can define for the most divisible numbers for their size. And the easiest way to define a club of the most divisible numbers for their size is numbers with more factors than anything smaller than them. Of course, I can't just say the number with the most factors, or I could generate like a billion factorial probably has a lot of factors, but if we say the most for their size, it's a rather exclusive list. You know, you don't get a million and a billion on there. You get more practical numbers. You get 360, 720, stuff like that. Now, the superior ones are a stricter definition. And so we're not going to fully explain what the superior highly composite numbers are right now, but we can somewhat to a degree think of the first ones that we're going to name. We're going to just look at the first 10 of them right now as, in a way, the most efficient number for its size with a given amount of primes making it up. So like 2 is the most efficient use of 1 prime, sort of, and 6 is, in some standards, the most efficient use of 2 primes. Now, in between that, you might get others on the highly composites list, because, for example, 4 is highly composite. It has more factors than a smaller number. But under the superior highly composite metric, which is a little more complicated, we can sort of see 2 as the most efficient use of a 2 prime number, 2 times 3. 12 is sort of our superior highly composite number with 3 primes making it up, 2 times 2 times 3. And next is going to go 60, 120, 360, and those are all classic ones we're used to. And then we start getting to the larger ones that some may be less familiar with. So under the superior highly composite metric, the number with 7 primes that make it up that gets on that list is 2 cubed times 3 squared times 5 times 7. And that's exactly 7 times more than 360. And it gives us 2520, a powerful number. And then we get twice that, which is 5040. And that's a really powerful number as well. 5040 we recently passed in followers here, or subscribers or whatever. And well, no, we passed that one a while ago. We passed its clone recently, because it has a clone on the highly composites list, 50400. But we're just looking at the superior ones right now. So if that is the most efficient 7 prime multiplied together number under this metric, and that is the 8 prime number that gets on here, what about the 9 prime number? Well, it turns out the 9 prime number has gotten to 2 to the 4 times 3 squared times 5 times 7 times 11. It's superior highly composite, and it's 55440. And it is also, just since it's a normal highly composite, it also gets the trait of being the one with the most factors for its size. It has 120 divisors. It has the long 100 amount of factors. And if we look at the highly composites list in general, we could see that the one before that on the regular highly composites list, that clone 50400, had 108 factors. So this is the smallest number with more than 108 factors. Once again, much more divisible than numbers like a million or even a billion. Those are not very divisible numbers. So that's the number we're about to pass here now. How amazing. I love you all. Quite awesome. So let's see what else I wanted to talk about briefly. I'll probably save this more for a future stream, but I wanted to take a little note about these cloning things I showed in a short recently. Pretend that also said 3, 4, 5 there. It's kind of fun to see what numbers stretch things out. Now, secretly, some people noticed the pattern is that here, to get from that to that, we have to multiply by 1001, which that turns out to be in disguise. But that makes it kind of fun that 1001 factors into 3 primes in a row. So you can kind of make it a game where it's like pretending you're just multiplying something by a lucky number and then the next 2 primes, and you've snuck in 1001. Then it's interesting, too, how what we need to multiply this to get there is we could have seen it as multiplying the original by 1001001. If I multiplied the original by that, I'd get that. But also, if I multiply the original by 1001, and then I multiply that by 1000 with more O's this time, is that the right amount? We need 6. Yeah. Then if I multiply it by that, then that, it was secretly multiplying it by that. So I have two ways of getting to some of these. I could multiply it by this secret 1001, and then by this, which is secretly a stretched out 1001, or it's like an alternating 1001. And I like to call these fellows hollowelevens because I call hyperelevens the ones that are all ones. So they're like hyperelevens with periodic zeros sometimes put in them. And they have some fun traits, so they can combine into each other in weird ways. And it's also kind of neat in general that they, if we look at longer ones factorized, we see patterns sometimes. Like this one snuck in a 9901 in a factorization, snuck in 9999001 in a factorization. And there's a lot of fun games you can play with those. And so a fun thing to do if you want to conjure your own divisibility tricks is you can look for numbers that are composed of zeros and ones in a kind of symmetrical way or periodic way, and numbers that are like hyperelevens or hollowelevens or stuff like that that I nickname are going to do cool things when you multiply them by numbers. And so see which of those have neat factors that secretly, if you multiply things by, turn into that. And do I have the other example here? Maybe I left that one inside the other example, but if I take, actually I remember it, so that's okay, I'll write it here. If I wanted triple a number, like 345, and I wanted this time take a 3-digit number and I want to make it happen 3 times, well, what am I going to do? Here I was doubling and doubling. I never got a state where it happened exactly 3 times in a row. Well, what I need to then multiply it by is 101001 secretly. So to get that, I need to know this thing's factors, and they look kind of neat. This thing's factors are 3 times 333,667. It looks like all threes rounded. It looks like a third rounded and then 2/3 rounded of 1,000. You know, like round, that would round down, that would round up. So turns out if you multiply a 3-digit number by these, you get it 3 times in a row. So that this times that would be 345,345,345. So how did I find that? Just by realizing this is what would make that happen and then seeing what factors made that up and being pleasantly surprised. So they're going to do cool things. Also interesting, as usual, to try and think about generalizing them, what they would mean in different bases, and to think of if you could write a formula for what it meant. Like if I want to say, how do I describe what this is in any base? This is going to mean I have 1 of something, and that's the norm, b's, squareds, cubes, fourths, fifths. This is going to mean I have whatever the base number is to the 5th power plus 1. So numbers that are this form in some base are numbers 1 greater than a 5th power. What about numbers that are like of this form? Well, I have a ones place. In base 10, I have ones place, 100, and then like 10,000 place, and then I got my million place. And so what's happening is I'm adding 1 of every other power of 10. The 0th power of 10, the 2nd power of 10, the 4th power of 10, and the 6th power of 10. So I could write this as a sum, the same way I might write an infinite sum, but only going up for a few numbers, where 4 times I'm starting from the 0th power, adding in an even power of 10. I'm adding 10 to the 0th power, plus 10 to squared, plus 10 to the 4th, plus 10 to the 6th, equals that. And if I was writing this in a different base, it would just be a different base number doing that. So then I could also say, what if I had a number like with 2 zeros in between each one? Well, this number in a base is still adding 1 of each of a periodic thing, but this time it's the base numbers that have a Threeven exponent, 0, 3, 6, 9. So this would be all the Threeven exponent ones getting added in. And hyperelevens in general, where it's all ones, are essentially adding one of each power of the base, including the 0th power, which is 1. So a lot of fun, neat stuff that those do in all sorts of bases. They're sort of inherently interesting numbers. Also, like I mentioned the other stream, kind of crazy when it struck me the other day that when I was thinking about hyper 11s, I think of them as a rare type of number where if you're made up of all ones, then there's a lot of different types. You can have numbers that are all ones or even just all of a single digit. And then you could have ones that have all the different digits of the base, pan-digital numbers, and all sorts of stuff in between. But when you get down to binary or base 2, there's not any in-betweens except just the number 0. Everything in binary is either the number 0, a hyper 11, or pan-digital, because inherently it needs to just be 0, all ones, or a mix of the zeros and ones that make up the base. And the hyper 11s in binary are very important. They're Mersenne numbers. They're 1 under powers of 2, very important type of number. Check out my hyper 11s episode for that sometime. And this will all return with a vengeance when I do a hollow 11s episode. In fact, hollow 11s also have another superpower that some of the hollow 11s, not all of them, but some of the ones where you have a 1 just at the beginning and end, and the right amount of zeros in the middle, in binary, are certain numbers 1 greater than a power of 2, and there are certain numbers greater than 1 more than certain types of power of 2, are known as Fermat numbers, and the numbers known as Fermat primes, which are the ones of those that are prime. So there is an extra restriction of which type of these it is, because a Fermat number is essentially 2 to the 2 to the n plus 1. So you need a particular amount of ones there. But the Fermat numbers that are primes turn out to secretly relate to which polygons are constructible with a straight edge and compass. Someone's wondering if any of the clocks work. Luckily not. Whenever I get a working clock, I've ensured that it stops ticking because I want it to be right twice a day. I don't want it to be trying to keep up with the right time, worrying about how well it's getting its job done. As long as it's staying still, pretty faithful, it'll be right twice a day. So, someone's wondering about how primes are always evolving and how we found biggest one recently. Yep. I forget exactly when we found the latest few, but the ones that we found recently, the biggest primes that we know, it's either 8 or 9 out of the 10 biggest primes we know are this type, maybe possibly even up to 10 of them now, but like somewhere from 8 to 10 of the biggest primes we know are this category called Mersenne primes. And those are hyper 11s in binary. So if you were talking to a computer, the biggest primes we know are literally millions of ones written in binary, no zeros in the mix. And they're a lot of ones, but the exact amount of ones happens to not only be a prime number amount of ones to us, but also be the number in binary is also prime. So let's see. I have theoretically 20 or 30 more minutes to chat because I am going to hang out with a friend and do some random filming or whatever later. Now that I'm recovering from my surgeries, luckily I am stuck at home a little less. But that won't mean I'm not going to obsessively film still. But I think I may take a little trip to the marina later today, possibly with a friend. To get some fresh air and see what cool birds I can find. Now, good thing I reminded myself of plants or of animals because they remind me of plants sometimes, and plants remind me of what I want to show you right here. Got a cool type of plant right here. And I'm not talking about my candle holder berry, which, yes, this is technically botanically a berry. Whether it's a pumpkin or not is the debatable thing, but it is a berry for sure. Now, it does work as a candle holder just great. That's not what I'm referring to, though. What I'm referring to is I've mentioned that one of the cool plants in my yard that I want to make a snack break episode about sometime is a cactus fruit. And that's because some cactuses make these fruits that some call prickly pears or other things. They have many names. And you don't want to touch them with your bare hands because they have all these micro spines. But I got one in a little glass container here. Now, this one doesn't look fully ripe. They normally can get a little redder, but this one fell. So unless it got knocked off of the tree pretty hard, the fact that it fell on the ground is a good sign. Now, let's get a view of this. And like I said, I can't touch it because now it looks like, let me get a focus on this. It looks like there are just these little patches that look maybe like a needle or something. However, what you might not be able to see as easily is those little patches have, there we go. This is hard to get it focused. These little patches have these hairs on them. They're not actually hairs. They're little like stingy types of hairs that act like little, they feel like splinters. When I touched one of these a year or two ago and didn't know how careful I had to be, I thought I was just dodging those bigger dots. But if you even brush one of those bigger dots, all these micro hairs get in your hand like splinters all day. They're insane. So I'm going to have to figure out a safe way of cutting into this later. I will, of course, film it for some purpose or another and see what it tastes like inside, because I have eaten the inside of them before and they're good. They have these seeds that I'm pretty sure you need to spit out the seeds because they're pretty big, but they taste cool. And it's pretty neat that they come from a cactus. So if you ever see one of those, beware, but you may want to look into it because although it may be dangerous, if you do your research, it may have an edible fruit. So that may be a task I may convince my friend to help me with later, dissecting a cactus fruit. And it is weird that it has such a defensive mechanism, like the Magic Fellow mentions, that fruits typically do want to spread their seed. And here's my theory for it, is that maybe the spines don't affect all types of animals. Like maybe birds know how to avoid the spines or something. And like, I don't know that about this particular species, but there are some species that they're fine for birds. For example, certain hot peppers don't affect birds in the same way. So birds can eat them, fly somewhere else, disperse the seed somewhere and help the plant spread its seeds. And they would prefer that than humans eating it and spreading it not as far without the flight. So maybe they're trying to scare off mammals and attract something else to spread the seed that helps them do it better. But it is an interesting question when plants are so defensive about the part that I'm being like, I'm trying to help you do your job. Like, I'll put the seeds wherever you want me to plant. I'll let you try and grow. I'll put them in the dirt. You can have your fair chance. But you won't even let me help you disperse your seeds without stabbing me. So it's true that I prefer the non-stabby plants, but I do have a bittersweet respect for it. So, yeah, it is interesting. I'll do an episode at some point about how birds aren't affected by hot peppers in the same way. And that'll just be when I want to do an episode where I eat really hot stuff too, which will ruin me, but it'll be funny enough. And it'll help prove things about the Scoville scale. But it doesn't affect birds in the same way. So that's the example that made me think maybe cacti are the same, but I'm not sure. My bigger question is that I know some types of cacti can be fried up and cooked and eaten other ways, and I want to figure out if the type I have can be edible in other ways as well. Of course, I got to do my research before I'm going to start cutting into it and cooking it, but I need to find a cactus expert somewhere. So this I got to be really careful with. I can highly imagine myself leaning over after the stream and just like flattening it that way. As those of you who are here on my last stream may have seen, I already got a combo class injury this week. And yeah, it looks worse this stream than last time, but it's not that bad. But what happened was I stepped here once the desk was sideways. And I didn't realize that this bit was going to collapse out and break under, and I must have smashed onto this nail. So that is actually probably the most the combo class has hurt me yet. So I'm very safe when I play with fire and stuff, but sometimes I step on these things recklessly. So be careful out there. Luckily, that was in the outro shot for the last episode, so at least you can see all the stuff that it made fall. Actually, not the next episode, the one coming after that. The next episode will be coming out tonight or tomorrow, depending on how much of the edit I get to feeling finished with. Either tonight or tomorrow on the main channel, there will be an episode about negative numerical bases. And then sometime around later next week will be the following episode. Because I'm trying to stay on a roll with one every 6 days. And I also have a lot of short ideas stacked up that I stacked up while I was having a harder time filming during me having COVID. So now I'll get back to making the short ones every day as well, probably. Today's was about these fun facts, and we'll see what tomorrow's will be about. But as some of you know, the main channel is my priority, so those are the episodes that I really care about getting my cool ideas finished in a good form for. So I knew there was a good chance this channel would surpass it because shorts do better. But I wanted to feel less perfectionist about this channel anyway and have my own bonus channel to just play around with. And of course, it did skyrocket past the other channel, but we'll see who takes the lead in the long term. Now, I am going to cut off at probably 10 minutes from now, if not a little sooner. So if anyone has any questions they want to ask, feel free. In the meantime, I'm just going to stack some of these whiteboards to the side and do a little bit of final chatting. Now, let's see what else we have to think about today. I shouldn't have left my clocks out again because it keeps raining here at different unexpected times. And then when it rains and I leave certain clocks out, once I've already shattered the glass surface of them off, then they get warped. Like this fella still has his glass surface. So this one does just fine when it rains. But this fella doesn't have its glass surface, so it's starting to warp a little bit whenever I leave it out in the rain because the glass already broke when I was doing modular math tables. So this one maybe I should put back in my room after the stream just because I can predict rain possibly recurring out here. Now, I guess I haven't fully shown what the desk currently looks like from a full angle, so let me move you guys back for a moment and you can see a little more picture of how my desk wound up. Now, it actually works pretty good right now, although the desk itself over there, what you'll see is, well, collapsed. It made an accidental sideways little like desk table thing for me. So it's like a new type of little table desk now. Here you got, on this end, there's just a big post over there that used to be part of the top or side of the desk. I'm losing orientation of which way it normally was. Then you got what was inside the desk, that broken honeycomb stuff. But then, since it all snapped sideways and reversed, now I got like a little news anchor corner right here. So it actually might be functional enough to keep it like this for a couple weeks. I have like a little place to put my candles. I could, stack some items in my little shelf if I need to demonstrate something. So that works pretty well. I could have a little contained dice rolling arena right here if I need to roll a bunch of dice at once and measure their results. And whoa, this guy got messed up. So let's move back a little closer. Now, who knew that this was what was inside the desk? I sure didn't until, like, this desk used to be in my room before I brought it out here. And the combo class took a hold of it. And it's a really sturdy desk. Like, before I put it through absolute torture and rain and fire and hammers and stuff, it was very sturdy. And so I'm actually pretty surprised that this is the majority of what was in it. This cardboardy honeycomb stuff. Huh? You never know. I guess when you have a thick layer on each side, and there's enough of cardboardy stuff at the right angle, the cardboardiness adds up and it's strong. Who knew? However, when it rains, now that this is fully exposed, we'll see what the rain does to this. Remember, my motto is no, this isn't, I wouldn't call this my motto. This would be a rather weird motto to have. But remember, one of my expressions I say around here is that although you may call stuff like this desk broken, if we can still see this much of it, it could be more broken, and it will. So, thank you all for joining me here. We'll have 5 more minutes of wrap up and chat and thanks and such. And then I'm going to go have an interesting day and figure out what I get into. And I wouldn't be shocked if I can get myself down to the marina if I spot some cool enough bird or plant to film for you guys and show you tonight or tomorrow. Because that's why I want to go down there, is that you can catch some good wildlife. And I'm a big fan of how nature can refresh you. And so, in between your partying and your reading and your doing your job, it's good to get a little bit of time looking at plants and animals and breathing in some fresh air. And like right here, we got leaves falling by me. I find that rather refreshing. And so in my yard, we get a good amount of cool plants and animals. But the marina has a whole new set of birds. So if you go down to the marina, there's a pretty decent chance if you walk around a bit that you'll spot either like a heron, an egret, definitely some types of gull or hawk or stuff sometimes, occasionally turkeys. There's like weird types of bird that roam down there. I haven't been there in a long time though, and I'm worried that they built too much like road and like human stuff in some of the zones, because there were a few of the zones that remained protected that they weren't allowed to build on, and there were other ones that the city owned that the park district didn't own that they did end up like selling and building parking lots on and stuff. And so I hope it didn't get too humanified. I know that they took down this cool place called the Brickyard, and although there's still a place called the Brickyard there, I don't know if it still has all the bricks that made it have its name, because it was on top of landfill. It was on top of all these bricks. So luckily I have quite a lot of documentation of the way this town was 5 or 10 years ago when I was getting into all sorts of mishaps. But I will, of course, keep you posted if I find any cool birds or animals down there that are worth interacting with. I saw some cool geese here the other day, and I wanted to film them, but they flew by so quick, and they were honking, which is why I spotted them. And they were in a very stereotypical V shape. Like, some birds don't do that, but some birds, like, seriously do that stereotype V. I heard they have an interesting dynamic of when they switch who's at the front of the V. I need to look more into that before I quote anything about it, but I think they have some interesting ways of like switching off the V front one. That'd be cool if they're different types of birds made different shapes. So if you got a W and you got like a double spike, or you got one that's like the sine wave birds, or like what would be a cool shape for a bird to fly in? Could have how about a whole triangle? That'd be pretty crazy. It's like a V that's closed off on the back, just this like triangle of birds flying by. It'd be kind of spooky if you saw birds in like a star shape. That'd be a trip. Or like a circle of birds flying perfectly, just like a circle. They do weird stuff like that sometimes. Sometimes there's weird weather patterns that you'll see videos of that are even like titled as if it was some weird extraterrestrial or supernatural thing, that are often birds or bats or insects that when they go in these swarms, called a murmuration is one of the types, they look like a weird smog, or like if you imagine what like a swarm of miniature flies or dust would look like, birds from afar sometimes do that. So that's pretty wild. Someone's wondering how many decimals I'm going to calculate. I'm not sure what they mean by that. If they're talking about the title as being about the prime numbers don't really have any decimals, but calculating decimals is another story, or feel free to explain if you have any other thoughts about that. I am going to transition into ending this stream and thanking everyone for watching now or in the future. And thank you to all the nature around here. And let's hope that I spot some cool birds if I go on a mission later. And um, yeah, someone's saying you can overlook all of the flora and wildlife in your area. And that is true. That you gotta always keep your eye out and appreciate the little things of all the weird types of flower and plant and bug and stuff. And someone asked what my favorite type of animal was, and I would say that's too hard to pick. There's so many cool animals. A couple of my favorites are I'm a fan of for pets. I like my cats a lot, so I'm a little biased toward cats, and other types of jungle cat are pretty cool too, like panthers and stuff. But I'm also biased towards certain types of birds. Birds are pretty awesome. They have that elegant whole otherworldliness to them, another dimension they can travel than us. And so birds have something special about them. And I also am fond of certain amphibians are pretty cool, like salamanders and frogs are pretty awesome. And I would say the most underrated animal would be bees, because bees might not be like my favorite animal, but they're a top 10 or top 20 animal, and they're not treated with the authority and respect they deserve. Wasps, I feel more neutral about. Wasps are, they can help ecosystems sometimes, but I'm not putting them up with the bees. Bees are way cooler than wasps. But bees, I would say, are the most underrated animal. Um, all right. A lot of random questions. Can't answer all of them right now, but thank you to everyone for watching and stuff. I'm going to take off, but like I said, you can stay tuned for an awesome negative bases exploration popping onto the main combo class channel, either tonight or tomorrow. And stay tuned as usual for me to stream and drop shorts most days. Thank you everyone for all of the support. You're all so super awesome. As usual, I am still having a blast doing this. Still all love you all a lot. And we'll see you very soon. So everyone, try and get some cool learning. And remember to keep an eye out for all the cool plants and animals that you might pass by today.